I want to talk about how we find local minima and maxima of a function given its graph. So minima and maxima are just the plural of minimum and maximum. So a local minimum is just where the graph goes to the lowest point in a certain area. That's what local means. So you know what a minimum is. It's the local, it's a place where it's at the bottom, right? It's the lowest it could be. Well, a local minima means that we're just talking about in a small area. It doesn't have to be the lowest it will ever be. It just has to be the lowest in that local area. So a local minima local minima in general look like the bottom of a hill. It looks like the minimum, the lowest point in a particular area. So if we look at this graph, can we see if we see a place where it's the lowest in a particular area? So it looks like the bottom of a valley or the bottom of a bowl. And you should be seeing one place like that, which is right here. So this is a local minimum because it's the lowest place in this area. It looks like the bottom of a hill, or the bottom of a valley, I guess I should say, or the bottom of a bowl or something like that. So this is a local minimum. In this graph, is there any other local minimum, any other place where we get to kind of the bottom of a hill or the bottom of a bowl? So you should be seeing one more place, and that's right here, is another local minimum. Again, local minima is just the plural of minimum. So this is asking us if we can find where are these local minimum points. So there's two local minimums, or two local minima in this graph, and one of them is here and one of them is here. So the local minimum here is at x equals 0, right? So usually we ask where is it happening? So it's happening at x equals 0. So happens at 0. And over here, let's see what this is. 1, 2, 3, 4, 5, 6, 7. So this graph has local minima, or this function has local minima at 0 and 7. Okay, so let's talk about local maxima. So again, maxima is just the plural of maximum. So if we look for places where this graph gets to be like the top of a hill or the highest point in a particular area. So if we look, we should see two of those also. So I see one right here, and even though it comes to a corner, that's okay. It's still a local maximum. So this is a local maximum. And then there's another one right here. So this is a local maximum. So there's a local maximum happening at x equals -2 and at x equals 3. And that's how we find the local maximum and the local maxima and the local minima. Now, if someone asked you what were the local maximum and minima, then you would tell them the y coordinates. But if they just ask you where are they, they're looking for the x coordinates. So we should be focusing on where this is happening in terms of the x-axis. So what's the x coordinate of it? So the minimum here is at 0. This minimum is at 7. The other maximum is here, and then this is here. Now let's consider the endpoints. So this endpoint right? It's going down, but it's going forever. So there's never a place where it's the lowest it's ever going to be. Now over here, let's look at this endpoint. This endpoint is actually a local maximum also. So this is also a local maximum, because it's the highest point in this area. Even though if it didn't stop, it might keep going up. It looks like it would, but it stops. So if it stops, it can always be the highest point in that area. It still is. So this should be at 8 if this is at 7, but let's go ahead and count 1, 2, 3, 4, 5, 6, 7, 8. So there's also a local maximum at 8. That one looks a little bit different because it's an endpoint, but it is still a local maximum. So that's how you find local minima and maxima of a function given its graph.